Welcome to qnawire.
Hi, so over here we're asked how many liters of carbon monoxide are required to produce 2 liters of CO2. So over here, the first thing that we need to do is to write down the balance reaction in order to produce CO2. And what we're going to do is to employ conversion factors. So we are going to require 2 liters of CO2. We know that according to ideal gas law, we're going to have that the volume is going to be equal to nRT divided by the pressure. In this case, the temperature and the pressure of the system is going to stay constant. So this implies that the volume is going to be directly proportional to the amount of mole that we're going to have of the system. Thus, what we can say is that 2 liters is going to correspond to an amount of CO2 times RT divided by pressure. This is going to be a conversion factor. Dividing this quantity is going to give us a result equal to 1. Next up, we know that 2 moles of CO2 is going to react with 2 moles of carbon monoxide. And similarly to that, we need to get that dividing this quantity by the amount of mole of carbon monoxide times RT divided by P is going to give us the volume of carbon monoxide that we're going to require. So, as you can see, the amount of mole of CO2 is going to cancel out. The value for R cancels out, T cancels out, pressure cancels out. 2 divided by 2, this is going to give us 1. Sorry, over here it would be 1 liter corresponding to that value, 1 liter of CO2. And what we're going to get is that the volume of carbon monoxide that we're going to require is going to be equal to 2 liters as well. This is a consequence of ideal gas law. Since the volume is going to be directly proportional to the amount of mole, we can directly employ that instead of the amount of mole, considering that temperature and pressure are going to stay constant through the reaction. Notice that we're going to have a 1-to-1 relationship in between carbon monoxide and CO2. So the answer over here is going to be directly 2 liters.